Okay. Forgot to turn the video on, so we got the setup. 7.5 number 1, we got everything set up here. And we have graphed our 3 constraints that came from our chart. And where is the green one shaded? Wait, where's the green one shaded? Yeah, down, right? Below. So think about, we have to be above the red line, above the blue line, but below the green line. I think we are in here. Would you agree with that?
Yeah.
The answer to the question is going to be one of those points. All right, now this one's kind of obvious. It's a very easy problem, but I'm going to go through the whole process as though it weren't so obvious. So I figure out what these 3 points are. Shoot, I don't know any of them. How in the world am I going to find those points? Now pretend you're me. I don't have graph paper. There is no way I can tell what that point is. How am I going to find the point where my blue line and my green line intersect? Substitute or eliminate or Kramer's rule or inverse method, whatever flips your switch. But somehow we are solving the system of equations. This isn't an inequality now, it's a system of equations. And that point, this is why I like colors, that point is blue and green. So that point's these two. So you can substitute wherever you want. You know me, I'm going to eliminate. So I'm going to multiply that one by -5. 5 times 180 is that -900? So I got, for that, I got x to be 10 at that point. And if x is 10, it looks like 40, y is 140. Anybody else get that for that point? All right, then I move to another one. I'll find this one now. This one is the intersection of blue and red. I got 30 for x, and that'll make 60 for y. And finally, green and red. I hope I'm doing this right. I got 70-20 for that one. How do those points look? Are we in agreement with those?
Yeah.
Okay, so this is gonna happen. Usually we don't have to find so many. Sometimes, depending on the shading, these intercepts are involved, but for us, all of our points were out here in space, so we had to substitute or eliminate Kramer's rule something to find all of that. Okay, now what I want you to do is find the cost at each point. So remember, the cost is 10 times the A's plus 5 times the B's. So if I buy 10 A's and 140 B's, what will be my cost at this point? 10 times 10, 5 times 140, 800? So that one's gonna be 800. So at that point, if I take this plan, I'm gonna spend $800. All right, what about here? 30, 60.
600.
600. Thank you. And what about this point? 800 again. So what are we going to tell these people to do? What is ultimately the answer to the question?
30 A bags.
You want to buy 30 A bags and 60 B bags, and it's going to cost you $600.
Are you looking for the cheapest?
Yes.
I thought you
To
wanted
minimize cost.
And then if it like said maximize, we would go for the highest.
Yep. So these problems, the girls are up here talking, these problems find maximums and minimums. So if we wanted to spend, we would never do this, but if we wanted to spend as much money as we could, maximize, right, then it would be the highest number we'd be looking for, not the lowest. All right, well, that sure was fun. So now, we get to do it all over again. So here we go, let's see if we can get this one done before we run out of time.
What's your birthday? January 1st.
All right, instead of chatting, you should be filling in your chart. While I'm here trying to get this all figured out. This is problem number 2. You're filling in the chart. So we have A and B in total. L, M, and H is low grade, medium, high, cost. All right, here we go. 2 factories. It needs to supply 24 tons of low grade. So where does the 24 go? Total low. 6 tons of medium. And 30 tons of high. Those are the totals. Factory A produces 8 tons of low, 1 medium, 2 high, and costs $2,000 per day. Factory B has 2 and 1 and 8, and it's $4,000. How many days should each factory operate? So X will be the number of A days, and Y will be the number of B days. Does that make sense to you, since that's the answer, since that's the question, right? How many days, what's X, what's Y? Now, what are we trying to do? Is this another minimize problem, or do we want to maximize this time? Minimize again, and we're minimizing cost. Normally in these problems, we're minimizing cost and maximizing profit. That's what's the setup is. All right, so what's our cost gonna be?
200x.
Was it 100 or 1,000? 2,000x plus 4,000 y. And what are my constraints? Top row, what's top row say? 8x plus 2y. We need a symbol.
The blue one.
Shade, it's gotta be an inequality. Greater than or equal to. If I tell you I need 24, can I get by with 23? No, but can I get by with 25? Yeah, greater than or equal to. All right, then, x plus y, greater than or equal to 6. And 2x plus 8y, greater than or equal to 30. Everybody okay with that? And then, of course, the two understood ones, which you can write down or not write down. We're graphing in the first quadrant only, so we've automatically assumed X and Y are positive. All right, I think I can use a scale of 1 this time. The numbers look reasonable. So if X is, my green equation is the first one. If X is 0, Y is gonna be 12. And if Y is 0, X is gonna be
3.
And like before, that is shaded out there. If Y is 0, X is 6. And if X is 0, Y is 6. And like before, that one is shaded out also. And finally, if Y is 0, X is 15, 6, 7, 8, 9, 10, 15. And 30 divided by 8 is what? 15 over 4, like 3.75 or something like that. Now, all of those are shaded outward. So, when I'm all done, if I were actually shading, when I'm all done, what would be shaded is this. Would you agree with me that everything, here's my black line. All that would be shaded? So the corner points of that shading are 0, 12. This guy, which I have no idea what he is, this guy, which I don't know what he is either, and 15, 0. So those are the corner points, the angles of this shaded in region. All right, now, what do I need to do?
Find those 2
I need to find those 2 points. So I'm gonna intersect green and blue. So here's green and here's blue. And then I'm gonna intersect red and blue. Now I'm gonna run out of time, but you know what you're gonna do now to finish this problem. You're gonna solve this system and get a point. You're gonna solve this system, get a point. And then what are you gonna do? Then you're gonna have 4 points. You're gonna have these 2 and these 2. What do you do with those points? Plug them in right here. And the little one wins, right? And that's how much paper, or how many hours you're gonna operate each battery. Okay? We'll do a couple more of those next time, and then we will begin reviewing. I'll figure out when we're having a test, and it's not too far away, next week sometime.